Welcome back to part 2 of our video. We are in the process of finding degrees of freedom that will help us find our T star, our critical value. Okay, so we used the conservative value, degrees of freedom, 100 minus 1 gives us 99. So if we were to do this conservatively, I would have to look up 99 degrees of freedom in my table B for a 95% confidence interval. So here is our beautiful table B. Isn't it lovely? And we learned if our actual degrees of freedom is not on there, so 99 is not on here, you have to round down. So I would go to the 81 and go over to 95 to get a degrees of, or a T star value, a critical value of 1.99. So a T star of 1.99. Okay. So if I'm doing it the conservative way, I would plug 1.99 in here for my critical value. So I'm just going to recopy that. 1.99. Everything else is exactly the same. And then I'm just going to put that in my calculator and figure out what it is. So actually doing the math. So let's see how this goes. So 9.3 minus 7.4 gives me 1.9 here, plus or minus 1.99 times the square root 4.7 squared over 100. Plus 4 squared over 100. So plus or minus 1.228. And that'll give us a confidence interval of, so I'll subtract that answer. You see that? So 0.6718. For my lower bound, and 1.9 minus, oh, I don't need minus, I already minus, I need to add that answer, gives me 3.128. If I want to go another one, I guess I can say 2, but usually 3 decimal places is okay. So this is the conservative one. That's my conservative answer. If you wanted to go the technology route, which I don't blame you, it's what we'll actually most likely do, we're going to just go to our test. So I think I said we're going to use option 0 for a 2-sample T interval. Now they give you 2 options. They ask you at the top if you have the data or if you have just the stats. The data would be if they didn't give me these things, and they just gave me all the raw numbers, and I have to enter them in list 1 and list 2. But in our case, we don't have that. We just have the statistics. So I'm going to enter in my things. Please make sure you put the right stuff in the right spots. Okay? So my x bar 1, we were using x sub n, so 9.3. That standard deviation was 4.7. That sample size was 100. Next one was 7.4. Then we had 4, 100. Confidence level is, in fact, 0.95. I don't want pooled, so I hit my arrow button down and hit calculate. When I do that, all the beautiful things are going to appear on my calculator. So, notice how it gives me my degrees of freedom. So, 193.06, blah, 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 blah. Much different than 99, right? This is why it's so different, right? This is why my table is much more conservative, right? It's a lot lower. The lower you go, the wider it's going to be. So my degrees of freedom, 193.065. It's good to go to like 3 decimal places here if you can. You don't want to round that sucker. And then if I scroll down, oh no, I thought it told me my t-value. It does not. So I need to find my t-value. And how do I find my t-value? We don't technically need to know what our critical value is for my t-star in this case, since the calculator does it for us. But if you're interested in knowing, we're going to do our inverse t using, so if it's a 95%, so that would be 1 minus 0.95 divided by 2. So that's my area. 0.025 using 193.065. So I go to second vars, inverse t. Oops, too far. 0.025 degrees of freedom. Paste that on in there. And I get a t-star of, and we always use the positive version, 1.972. But again, I didn't really need all that unless you wanted to put it in here. So if I'm going this way, using it with technology, okay. If you're going to use it with technology, it's okay if you leave it as this without substituting this in, maybe until later, as long as you're specific about what degrees of freedom you used. So you need to either say this with this formula, or you can go the conservative route. Either one will be counted as correct. So if I want to substitute it in, I might as well. So 9.3 minus 7.4, all the recopying, use my new critical value. And then I got my answer, not having to do any math, but just using my calculator. So that's still there. Calculate that. Thinking, thinking, thinking. So here's my answer. 0.6827 and 3.1173. Okay. So this is my with technology method. This is my conservative method. You pick one that works for you. Either one will be fine to use. So we have our interval. Yay. For my conclusion, I'm probably going to use this one just because it is the more accurate one, right? Less conservative. Gives us a narrower range. And you want to have a narrower range because it gives you less values, possible values for the difference in the means. So now we conclude. So, conclusions for confidence intervals always start the same way. We are 95% confident that the interval from 0.6827 pounds, I'm including units here since it's means, to 3.1173 pounds contains the true difference, because we're talking differences here, the true difference in the mean weight loss for the two diets. Okay. Tomorrow you'll see an example of this where they give us the data and you'll have to, since it's, spoiler alert, it's smaller than 30 for my sample size, you'll have to make some kind of visual, whether it be a dot plot or a box plot, to see if you can assume normality and go from there. All right, have a good one, guys.